Ladies and gentlemen, good day. Welcome to join this webinar. Today's webinar will invite the members of the joint working group of IEA and WFEO on the GAPC, that means the graduate attributes and the professional competencies of the engineering education, and to report the progress we have been made since last November. We have had the first meeting in Melbourne when we had the WEC 2019. So despite of the COVID-19 pandemic, the working group has worked very hard and made significant progress on the project. Today, we're going to invite 5 speakers to give an introduction of the proposed updating of the GAPC and to facilitate the consultation among WFU members. So before we start the presentation, please allow me to make announcement for the participants. First, how to make comments. You can using the chat box to make your comments and send either to every participants or to all panelists or to selected panelists. So make your comments, use the chat box. The second announcement is about how to pose questions. Please use the Google Sheet provided with the link which is provided on the top of the chat box. Just click that link, you will open a Google Sheet on which you can write down your questions with your name and organization. All questions on that sheet will be recorded. Some of them will be answered during the webinar when we have time. Others will be answered afterwards and uploaded to the WFU website. So now let's start the presentation. Let's welcome the first speaker, who is Professor Özgüler, the chair of the WFEO-IEA Working Group. He will give us a summary of work done to date and key areas of the change in the IEA GAPC framework. Professor Özgüler, please.
Thank you, Professor Gong, sorry. I will share my screen first. Okay, can everyone see the first page? I guess
yes,
it should be. Yeah. So first of all, I would like to thank Professor Gong, Dr. Kanga, and all of WFEO. This is a tremendous event and very big help to the working group in the coming days. So I would like to give a description about the nature of changes and try to summarize what we have done up to now. Of course, in 10 minutes, this is difficult to do, but let me start right away. I have a list of contents here, but I'm not going to go over them one by one. Start with the definition of GAPC right away. So graduate attributes and professional competencies, how are they defined? Graduate attributes is a set of individually accessible outcomes that are indicative of a graduate's potential to acquire competence to practice at the appropriate level. The attributes are clear, succinct statements of the expected capability of the graduate. Professional competency profiles, on the other hand, are the elements of competency necessary for performance that a professional is expected to be able to demonstrate at the stage of attaining registration. Now, why are GA and PC relevant to IEA? Well, this is described in the requirements of, among the requirements of rules and procedures documents of IEA. So that can be considered the constitution of IEA. The first statement here says, the graduate outcome standard applied for accreditation by a signatory is substantially equivalent to that of the Accord graduate attributes exemplar. So if we have a potential signatory aiming to become a signatory in IEA in the relevant Accord, the graduate outcome standard of the organization, candidate organization, should be substantially equivalent to the graduate attributes that we are going to describe a little bit in this and next presentations. Competence profiles applied by the jurisdiction, I'm reading the second statement now. Competence profiles applied by the jurisdiction of an agreement partner are substantially equivalent with those specified in the professional competencies document. So if there is an organization who would like to be professional organization, who would like to be a member, a partner of the relevant agreement, the competence profiles applied by them should match up with the professional competencies document that we are going to describe today. Now, why are GAPC also relevant to WFEO? It's, again, in the WFEO constitution, the objective is described as to encourage the application of engineering and technological advancement to economic and social progress throughout the world. There is, I cannot imagine a better way to do this than really help IEA develop the graduate attributes which WFEO is doing. Now, in the next two slides, I have listed the work done up to now from October 2019 until now, but this is too long, and because of time, I'm going to just summarize it. Well, first of all, the whole thing started with a workshop, of course, started with the memorandum of understanding between IEA and WFEO and UNESCO, but there was a workshop at WEC 2019 that started the whole discussion. A questionnaire was distributed in IEA and collected. Many reports, surveys, investigations were examined. And after all this, in May 2020, the first complete version of the GAPC changes proposal was ready. Okay, so these two slides I'm really skipping. But what are the tables that characterize GAPC? Well, there are 5 tables. The first one, table 1, is range of problem-solving capabilities that distinguish the 4 or 5-year program with engineer graduates from those that have a teaching duration of 3 or 4 years for technologists or 2 years for graduating technicians. The table 2 is on range of engineering activities. Well, for an engineer, these are complex activities. For a technologist, these are broadly defined activities. And for a technician, these are well-defined activities. And the boundaries are drawn in this range of engineering activities between these 3 kind of activities. The third table is knowledge and attitude profile, which can be viewed as describing what the curriculum of an engineering program must contain at a minimum. Now, table 4 is graduate attribute profiles, the assimilated knowledge, skills, and attitudes of an engineer described. And table 5 is professional competency profiles that are the main objectives of our activity today. Now, when you do a change in the graduate attributes or professional competencies, what does this entail? What are the implications? When a new entry in GA of table 4 is made, the questions arise, is this consistent with table 2? Is this consistent with table 3? Is this attainable in the relevant program with the length of the program? Is this measurable? Is this accessible? is this demonstrable? Now, demonstrable is relevant to the Higher Education Institute's program, which is undergoing or candidate for an assessment. On the other hand, measurable and accessible are the properties that are relevant to the organization which is doing the assessment of that program, engineering program. Similarly, when a change is made in Table 5, professional competencies, again, is this consistent with the Table 2 and Table 3? Is this attainable in the relevant program, which is the educational basis of the professional engineer? Is this attainable during the professional development after education? And is this demonstrable for the individual who is a candidate for registration? Now, let me give an example to this using Table 4 graduate attributes. This is on tool usage, level of understanding of the appropriateness and of technologies and various tools. Well, you can see the changes, deletions and insertions in green shade here. In the 5th row of this Table 4, there is this first column. The cell describes what an engineer should have as a qualification concerning tool usage. Similarly, in Table 3 and Table 2, you look at the engineers column, Washington Accord column. Well, they are supported by relevant cells in there. So the new entry, for instance, data analytics, which occurs in this cell, is supported by Table 2 and Table 3, but it is also easily attainable, for instance, by a separate course in computer science and engineering program. But it is also attainable in other engineering programs through a variety of activities scattered throughout the curriculum, because data analytics, as you well know, is the analysis of raw data in order to make conclusions. So this is easily implementable in the curriculum. This is accessible, measurable, demonstrable via the documents of individual students' work in the span of 4 or 5 years during the education. Now, as an example to the contrary, if this item was not data analytics, but something like database systems or parallel computing, then this would not be attainable even in an electrical engineering program, which is the closest, I think, discipline to computer engineering. Now, let me say a few words about the difficulty of assessment. This is what we are talking about is outcome-based evaluation, and it involves performance evaluation at its core. So, for instance, whether a student has attained the graduate attributes or not is as difficult to determine as whether an academician has reached a level of professorship or not. Whether an engineer has attained the professional competencies is, for instance, as difficult to determine as whether a company product satisfies all the specifications or not. The level of difficulty in these are no more, no less. So we need to be aware of this while judging the appropriateness of the changes suggested to GAPC. Now, your contribution is really needed. There are 2 documents published on WFEO website. The first one describes the work carried on up to now. The second one is the 5 tables with changes, so you can make your changes and send it directly to me. Thank you very much.
Thank you. Thank you, Professor Özgüler. Our next speaker is Dr. Marlene Kanga. She will talk about an overview of the framework and the proposed changes to the graduate attributes, that is dealing with the Table 4, as mentioned by Professor Özgüler, of the IEA's GA and PC framework. Marlene, please.
Thank you very much, and good evening, good afternoon, and good morning to all of you, and thank you very much for joining us in this very important consultation webinar on this very important work. And I would like to welcome Professor Özgüler, the chair of our working group, and all the members of the WFEO working group. For those who are not members of the World Federation of Engineering Organizations, a quick introduction. We are the peak body for professional engineering organizations, founded in 1968 under the auspices of UNESCO. We have more than 100 national professional engineering institutions as our members, and some 12 international and continental regional professional engineering institutions representing some 30 million engineers. And here you see a map of our global reach. So hopefully the work that we do will have impact in all these countries. And we are recognized and recognized associate of UNESCO and a co-chair of the Science and Technology Major Group at the UN. A key objective of the WFEO, in addition to the Constitution, which mentions our objective and purpose of the organization, is to advance the UN Sustainable Development Goals through engineering. And for this, we need to have more engineers with the right skills to develop the technologies and solutions for sustainable development. And so this project is very much part of that objective, to meet the needs of current and future needs of employers, industry, and the community. And we're working in partnership with our peer engineering organizations to meet this objective. So the peer organizations that are part of this very important project is, of course, the International Engineering Alliance, and Professor Özgüler is representing them as chair of the working group. The International Federation of Engineering Education Societies, and also the Global Engineering Deans Council. And they are represented on the working group by Dr. Michael Milligan, who isn't with us in person, but we will be hearing a video from him later today. The Federation of International Consulting Engineers, who represent the employers of the consulting industry. The International Network for Women Engineers and Scientists, which represents the networks of women in engineering around the world. The International Center for Engineering Education, based at Tsinghua University. And I welcome Mr. Kang Jincheng, who's going to speak later in this session and is a part of our working group along with other members. And the International Science, Technology, and Innovation Center for South-South Cooperation. So the International Engineering Alliance is an umbrella organization that provides governance for the 3 accords and 4 agreements that provide international multilateral recognition of the graduate attributes and professional competencies across some 13 countries. And I've listed here the 3 accords for the professional engineer, technologist, and technician, and the 4 agreements, again, for the 3 categories of engineering professional, and then for the APEC region. So our focus today is on the graduate attributes and professional competencies, which are the benchmark for the expected graduate outcomes and professional competencies, which are used by the signatories to establish substantial equivalence. So it's not a prescriptive standard, but it's a benchmark. And Professor Özgüler has given you some examples and explanation of that framework already. So we are working with the International Engineering Alliance through a memorandum of understanding, which has established a working group with both organizations. UNESCO is a key partner in this project as well. And in this work, we are advancing 3 key recommendations in the 2nd UNESCO Engineering Report, which will be published soon. And these state, government engineering educators, industry, and professional engineering institutions need to collaborate to increase the number and quality of engineers. There is also a need to work in partnership to develop the necessary international engineering education benchmarks for sustainable development. These need to be recognized across the world and form the basis of national engineering education systems for engineers with the right skills, especially in Asia, Africa, and Latin America. So you see here the members of our working group. In addition to Professor Özgüler, we have 3 IEA signatories from Japan, UK, and Australia. I mentioned some of the members of the working group who are speaking here tonight. We also have Professor Dr. Charlie Tan, President of Myanmar Engineering Council, and I welcome you also, Charlie, for being here today. And we have other members from the ICEE who are also observers on this program. So here we are today. We've presented the draft framework to the IEA annual meeting in June this year, and we're now in the consultation phase with stakeholders, which will go on for the next 6 months. The working group was conscious of the changes that have occurred in engineering and in society in the last few years. And these are some of the areas that were listed in the research that we accessed. We acknowledge that core knowledge, skills, and analytic background specific to a discipline and basic skills will continue to be needed. But IT skills, the ability to write code, reliance on 3D printing, digital skills, etc., will now also become core. And data-driven analytics, which was just explained in the previous speaker, will also become as important as digital proficiency and digital learning programs. Liberal arts will become important, as will multidisciplinary issues like social, legal, economic. And the complexity, scale, diversity, globalism, and disruptiveness will continue to increase for engineering problems, as will the need for inclusive and sustainable solutions. There will be increasing emphasis on entrepreneurial skills, risk-taking, and critical thinking. And engineers will have to learn to work collaboratively with diverse teams, including those in remote and virtual workplaces, as we have increasingly found in the COVID-19 environment. And of course, artificial intelligence, machine learning, automation, and other machine-machine interactions will have rapid growth. And here's just a quick example for civil engineers, one of the oldest engineering disciplines, where 90% of the work of civil engineers has been codified in excellent codes and standards, and much of the work that would take days and months can now be done by a computer in a matter of hours. And tools like building information modeling enable the digital twin to be prepared, as an example here, so that a construction project can be modeled entirely, checked for errors before you even hit the ground, saving time and money. So this is the new normal for civil engineers, and all engineering disciplines are facing this change. So the working group identified 6 key areas for change to change the framework, the GAPC framework. The first was to accommodate future needs of engineering professionals and strengthen the required attributes for teamwork, communication, ethics, and sustainability. Secondly, to address emerging technologies, including digital technology and lifelong learning. Thirdly, to address emerging and future engineering disciplines while retaining discipline-independent approaches. Fourth, to incorporate the UN Sustainable Goals and an integrated approach for technical solutions that also takes into account environment, social, cultural, economic, financial, and global responsibility. 5, to consider diversity and inclusion in the broadest sense, including ways of communicating. And finally, number 6, intellectual agility, creativity, and innovation. So these stars with the 6 colors will show up in the table that I'm going to discuss. I'm going to discuss the graduate attribute profile, table 4, only of the 5 tables that have been mentioned by Professor Özgüler. And in particular, I will only talk about the requirements for the professional engineer because of lack of time. But the full table is available for you on the WFEO website to view. So the graduate attribute profile has 12 elements which can be divided into 3 categories. The first is engineering knowledge, problem analysis, design and development of solutions, investigation and research using appropriate tools. The second is the engineer and society and the consideration of technical and engineering works on human, societal, and environmental impacts, and also ethics. And fourthly, it's the ways of working, individual and collaborative teamwork, communication, and lifelong learning. So you see here the graduate attribute table. The first column are the differentiating characteristics for a professional engineer, a technologist, and a technician. The second column is the requirements for the professional engineer graduate. And the WA stands for the Washington Accord, which is the accord that governs professional engineers' attributes. And the third column is the reason for the change. The red font is the change that has actually been made. And you will see that the changes are quite subtle and specific, but they are strategic as well to achieve the change that we need. So in item 1, WA1, we have retained all the core competencies conventionally that we have today, mathematics, natural science, etc. But we've added skills in computing as a key skill. In the analysis of problems, we've added, in addition to the capacity to analyze complex engineering problems and reach substantial conclusions using first principles of mathematics, natural sciences, and engineering sciences, we have added the capacity to research literature and also for holistic considerations for sustainable development. So here you have the sustainable development goals coming in. In the design and development of solutions, we have included the consideration of the uniqueness of engineering problems and also innovation, that is solutions which have not previously been identified, a very important little word that we've added. And the way the solutions are designed will meet identified, not specified needs. So it's not prescriptive, and it actually requires some critical thinking, as well as consideration of health and safety, whole of life costs, net zero carbon implications, cultural, societal, and environmental considerations. So here again, you see the SDGs and creative thinking coming in a very subtle way. We didn't make any changes to the need for professional engineers to conduct investigations of complex problems and research methods, including design of experiments, analysis, interpretation of data, and synthesis of information. But number 5, which is the last category in the knowledge section, is the usage of tools and appropriate technologies. We've expanded the ability to create and select appropriate techniques to also include prediction, modeling, computing, information tools, and data analytics to complex engineering problems and understanding limitations. So this is a new area that we brought in. Now to the engineer and society and the areas that the engineer needs to consider. We ask for sound decision-making frameworks that are informed not only by contextual knowledge, but also stakeholder consultation to assess societal, health, safety, legal, historical, and cultural issues. So these were there before, but we've added for sustainable development. So the ability to consult with stakeholders for sustainable development has been added. And this continues in number 7 for human, social, economic, and environmental impacts, where we've added to the previously included requirement for sustainability impact, we've added human, cultural, economic, and social, referencing the sustainable development goals. And the third category for ethics for the engineer and society, the third element is to apply ethical principles and commit to not only professional ethics, but technology ethics, data ethics, global responsibilities, and adherence to national and international laws, and the need for diversity and inclusion. So this is the new area that has come in. And then the way the engineer will work, we've added the need for collaboration, you can see here in red, to work, and the engineer will be required to work in diverse and inclusive teams in multidisciplinary and long distance settings, taking into account some of the remote ways of working that we have adopted so quickly in the last few months. For communication, we've added that the engineer will need to communicate effectively and inclusively on complex engineering activities with the engineering community and with society, and be able to comprehend, write, and present in a variety of ways, effectively considering culture, language, and learning differences. So this is going to be a new element for engineers. We made no change to project management, the ability to manage projects, economic decision-making, and to lead and manage in a multidisciplinary environment. But continual lifelong learning is a very important element, which will go on to the professional development cycle as well. The ability for independent and lifelong learning has been extended for the need for creativity, adaptability to new and emerging technologies, and critical thinking. So the importance of creativity and lifelong learning and the ability to adapt to new and emerging technologies has been added. All these tables are on the WFEO website, and we look for your feedback. Please send to the Secretariat by 31st August. Thank you very much.
Thank you, Marlene. Thank you, Marlene, for your elaboration of the updates of the Table 4. Now let's welcome Professor Kang from the UNESCO Secondary Center of Engineering Education to talk about proposed changes to knowledge and attributes profile, that is Table 3 of the IEA's GAPC framework. Professor Kang, please.
Good day, ladies and gentlemen. My name is Jincheng Kang from ICEE, International Center for Engineering Education, which is a Category 2 center affiliated to UNESCO. Just now, the last two specialists have given a brief account of the present project on the knowledge and attitude profile. We from the ICEE were asked to work with the working group to give some special summary of the proposed changes to knowledge and attitude profile, which is lined on Table 3 of the framework. So I am entrusted by ICEE to give a brief report on this. But first of all, can you hear me clearly?
Yes.
All right. Let's go on. So this table, overview of Table 3 acknowledges the knowledge and attitude profile. This table focuses on knowledge and attitude in curriculum. In this profile covers 3-level engineering programs, which was stipulated by Marlene just now, which is Washington Accord, Sydney Accord, and Dublin Accord. The changes aim to respond to changes in engineering for sustainable development goals set by United Nations, and engineering discipline development and ethics challenges, and also meeting needs of society. So this the reason for change, that is, one is the curriculum may contain appropriate basic natural science courses, and two, some social science courses relevant to the discipline. And alternatively, in place of the second point, some students experience, that is annexed to the capstone design, that require input from social sciences relevant to experience that may be required. And the curriculum may contain appropriate basic natural science. The reason for this, the curriculum may contain appropriate mathematics, data and analysis, numerical analysis, and statistics probability courses, along with computation and information theory experiences using contemporary tools. Yeah. And the curriculum must contain some basic engineering courses of the discipline, such as material science, fluid mechanics, heat transfer, dynamics, circuits, and other engineering disciplines, and so on. And each design experience of the students needed to be taken into the relevant considerations at the interface of other domains, such as science, law, art, humanities, etc., into account, and sustainability concepts, including Sustainable Development Goal Point 12. And additionally, the curriculum may include specific teachings on supporting factors of design. And the curriculum also need to transcend the theory and include teaching on the current technology and contemporary practice and thinking. Okay. The curriculum also need my next slide should be this one. All students' experiences of the curriculum need to be realized within the context that engineering has a responsibility to society. Every major design activity in the curriculum requires an integrated approach that take into account impacts on people, the environment, economics, social, cultural resources, and other impacts as articulated in the UN SDGs. Okay. And the curriculum also need to be up to date to reflect the contemporary practices and approaches. And the testings should encourage the students to ask questions, to brainstorm, and to consider alternative solutions and balance competing objectives. all students' experiences of the curriculum need to be realized within the context of the engineering. That engineering has a responsibility to society, and every major design activity in the curriculum requires an integrated approach that takes into account of the impacts on people, environment, social, cultural resources, and also other impacts that are articulated in the SDGs. I think this is a very short briefing of my presentation, which was focused on knowledge and attitude profile on table 3 of the framework. I think that's all for my presentation, Professor Gong.
Thank you, Professor Kang. Now let's move to the next speaker, Professor Charlie Tan, who is the president of the Myanmar Engineering Council. And he will talk about the proposed changes in professional competencies, that is table 5 of the GAPC framework. Charlie, please.
Thank you, President.
Okay.
Okay.
It's coming, yeah.
Do you see my presentation?
It will come soon. Oh, we lost you. Okay, you can share the screen again. Good. Good.
It's okay?
Yeah,
okay.
Yeah, it's okay.
Good.
Yeah, that it is.
Yeah. Today, in the consultation webinar, I'd like to present on the proposed changes to the professional competency table 5 of the framework. And as you know, I am Charlie Tan, the president of the Myanmar Engineering Council and the vice president of the FEED. Today, I would like to present the proposed changes to the table 5 of the professional competency profiles. Professional competency apply after an engineer technologist technician has graduated and entered the workforce. The aim is to ensure that there is ongoing learning and professional development so that the practicing engineer remains current in their discipline and keep up with changes in technologies and new development that will occur over a 40-year career lifetime. When I refer to engineers, I mean also technologists, technicians. That is similar requirement apply to each, but due to lack of time, I will speak mainly about the engineers to explain changes. The framework in table 5 is important because it is the benchmark for ongoing learning and career development throughout the person's career. Where a professional engineering institution is a signatory of the IEA agreement and has a system of registration of becoming a professional engineer, meeting the requirements in this table will enable recognition for the engineer under the International Professional Engineer Agreement, IPEA, with the post-nominal of NPE. Typically, the professional engineer will be audited for their continuing professional development to maintain their registrations. There are 12 elements of graduate attributes divided into 3 categories, which are professional engineer, engineering technologist, and engineering technician. Level of graduate attribute for engineer is complex, technologist is broadly defined, and technician is the well-defined. There are 13 elements of professional competency profile divided into 3 categories. The level of profile for the professional engineer is advanced. Technologies is widely accepted as broadly defined, and for technician is standardized and well-defined. In the professional competency profile, there are 6 commonly shared elements with the GA, which are engineering knowledge, problem analysis, design and development of solutions, ethics, communication, and lifelong learning. However, additional requirements have been added to the follows during the working life of the engineer. This is locating the GA and PC in the engineering pathway. When an engineering student is graduated from the accredited program, the student will meet the engineering education standards. When the engineer obtains training and experience after graduation, the standard for professional competency will be obtained. Then the engineer will continue the practice while observing the code of conduct and maintaining CPD. The working group has made several amendments to the profile. The amendments are highlighted in yellow. The working group proposed that there will be no personal pronoun being used in the context. Instead of the gender-neutral language will be used throughout the context. The working group does not propose any changes to the first element of the professional competency profile, which is to be comprehend and apply universal knowledge. This is because we expect that the engineer set the recognized standard for engineering education and has thus acquired the ability to understand the universal engineering knowledge. For the second element, to comprehend and apply local knowledge, except for the change to use gender-neutral language, it suggested that using of personal pronoun for all 3 categories is eliminated. Here, it is important for the engineer to understand local laws, regulations, and conditions when proposing solution. For the third element, problem analysis, the use of data and information technology has been added for professional engineer, and the use of support of computing and information technology has been added for technologists and technicians. This is continuing development of what has been learned during the engineering course at university. For the fourth element, design and development of solution, the importance of inclusive solution and stakeholder consultation has been added. This is continuing development of what has been learned during the engineering course at university, but now the engineer must consider the concern of stakeholders in society, consult with them and seek their opinions. The more complex problem may require more consultation. For example, if the engineer is developing a solution for a major highway, there would be need to consult with people in the villages and towns where the highway is planned impact on not only the people, but also the local government, business, etc. There will be positive and negative impact, such as increased traffic and noise, but also improvement for the economy, employment, and businesses. For the fifth element, evaluation, the importance of the evaluation and risk assessment in broad context has been added for professional engineer. These changes now involve the engineer in the impact on society and environment and economy. This is an integrated approach that has been advocated to advance the UN SDG. The engineer is not only developing a technically competent solution, but considering all the implications of the solution. In many cases, the best solution may not be selected just on technical consideration, but also on the impact on society, economy, environment. As the engineer increases their experience, these considerations would need to be evaluated. For the sixth element, protection of society, type of activity and responsibility to consider adding advancement of the UN SDG and eliminating the word public. The importance of consideration of advancement of UN SDG where relevant has been added. This is similarly engaging the engineer in the holistic impact of the solution being developed. For 7 elements, legal and regulatory, environmental and cultural has been added to the characteristics, which become legal, environment, cultural, and regulatory. The importance of compliance with relevant law and regulation, including to protect the environment and cultural heritage and gender-neutral language, has been added. It is important for all engineering solutions to be abide by the laws and regulation of the country. This is now expressed explicitly in these characteristics. For the 8 elements, ethics, diversity, and inclusion has been added to the characteristics, which become ethics, diversity, and inclusion. This is an important change because it requires that engineers work with diverse teams, not just more women engineers, but with a wide range of people, young and old, with different languages, and from different cultures and engineers that may be located remotely. That is distant from an office. COVID-19 is showing us that we cannot communicate effectively with each other even from great distances, and we must learn to work together as a team in the same manner. There is no changes in the 9th element, manage engineering activity. The last 4 characteristic as described below is about the expanding role of the engineering communicating the solution that had been designed, undertaking lifelong learning to remain current in the discipline, increasing experience to exercise judgment and taking responsibility for the decision made. For the 10th element, communication, the working group added collaboration, requirement for inclusive communication to the characteristics. The importance of inclusive communication and gender-neutral language has been added. For 11th element, lifelong learning has been eliminated, substituting continuing professional development. The importance of lifelong learning in the world of rapidly changing technologies and gender-neutral language has been added. For 12 elements, judgment, the need to exercise judgment and application of the knowledge and ability in broad context and gender-neutral language has been added. There is no changes in the 13th element, responsibility for the decision. Finally, the presentation above is a proposed changes to the level 5 of the professional competency profile. You can see that the changes that are proposed are small and strategic. They shift the focus of the engineer to also include impacts on society, environment, and economy. Learn to communicate and engage with stakeholders. Work in teams and engage in lifelong learning, especially in the new technologies. We hope that these changes will help the engineer to meet the needs to the community and society now and in the future. Thank you, sir. Thank you, President.
Thank you, Professor Tan. The previous speakers have introduced the proposed updating on the table 3, table 4, and table 5. Now we are going to listen the video speech from Michael Milligan, and he will touch a very important issue, which is not a dedicated table. That is the diversity and inclusion incorporated in the IEA's GAPC framework. Now, please listen to Professor Michael Milligan's video speech.
Good afternoon, everyone. My name is Michael Milligan. I'm the Executive Director and CEO of ABET, which is the accrediting body for applied sciences, computing, engineering, and engineering technology in the United States and in many other countries around the world. Today, however, I'm going to be representing IFEES, which is the International Federation of Engineering Education Societies. ABET has been a member of IFEES for a number of years, and I've been involved at the executive committee level for a few of those years as well. My talk today is to talk about these proposed updates to the IEA benchmarks, specifically in the areas of diversity and inclusion. So with that, I'm going to go ahead and share my screen with you so you can follow along. As I mentioned, I'm representing IFEES, and I just want to say a few words about IFEES. IFEES' mission is to advance and advocate for engineering education engineers around the world, primarily through leveraging the strengths of our members and stakeholders. Okay, so this statement in itself kind of hints to this idea of not just diversity, but also inclusion. So very much support any advances in this area, especially with these proposed changes to the IEA graduate attributes and professional competencies. Membership, 53 societies, 11 industry partners, representatives based in 29 countries, so purely a global organization. Again, everyone's focused on improving the quality of the educational experience and education in general in engineering around the world. I'm going to talk about diversity and inclusion again, and we want to make sure we think about ways how we can encourage students to work in diverse teams, inclusive teams, how we can communicate in that manner, how we can comply with certain requirements, and how we are paying attention to the environment and legal issues as well. My highlights are going to be in yellow for discussion, so I just wanted to touch on that, and as we go through the details. First, I just wanted to talk about the SDGs. We all know about the SDGs. I don't need to get to talk about what they are or why we have them, but my point is that to me, the diversity, inclusion, and the importance of creating diverse and inclusive teams of technical professionals is critical in achieving these goals. And so I don't believe we'll be successful in achieving these goals without, again, a strong D&I sort of makeup. And the way to start this, of course, is at the undergraduate level when students are in our programs, and we can help them practice good D&I, for lack of a better word, best practices. So getting into the details now, I want to talk about, too, the range of conflicting requirements and the extent of stakeholder involvement in conflicting requirements in this first area of range of problem solving. And the idea of range of conflicting requirements is, as we determine requirements, certainly if we are looking at from one point of view, it's highly likely that we won't either understand the full set of requirements, or those with differing points of view might actually have conflicting view of the requirements. So building strong, diverse teams of individuals that have the ability to look at things from a different point of view and then converge on sound solutions is going to be obviously important. Anytime we see the words sustainability, economic, social, that should be a key to us to think, okay, how can we improve the experience of students to get them focused on, again, building diverse and inclusive teams. Extent of stakeholder involvement in conflicting requirements, of course, here we're talking about encouraging problems that require collaboration across a large number of engineering disciplines. And so each one of those disciplines is likely to have a different sort of view of things, different experiences, and certainly getting multidisciplinary teams to come up with good, sound solutions to complex problems that will impact everyone's daily lives and so forth is going to require this opportunity to draw on people's differing experiences and viewpoints and so forth. So again, an opportunity to introduce D&I in these areas. Range of resources, we talk about including diverse resources. Okay, so right there you see that there's emphasis on especially people, data, information, natural, financial, physical, and appropriate technologies. But think about the people part, because that's where we have an opportunity to, again, to encourage this idea of diversity. And diversity takes on many forms. It's not just ethnicity, gender, race. It could be a multitude of things that include people's professional experience, their socioeconomic upbringing, their age, how much experience they have, et cetera, et cetera. So really taking advantage and leveraging diversity and making sure people feel included as part of those teams that will develop are going to be critically important to, again, to solving complex problems. All right, so the next one, level of interactions, again, and you see this idea of encouraging the impact of wider, just not just technical issues, but non-technical issues. So you see this socio-technical solutions, and anytime you see, again, that idea of society or social issues, you really need to think about, again, the kinds of teams that we're going to be developing to solve those kinds of problems. And again, it's going to be best addressed by those that are in that come from diverse backgrounds. Knowledge and attitude profile, you'll see here the idea of developing this sense for responsibility, professional responsibility to the public safety, and advancing the United Nations Sustainable Development Goals. And then again, economic, environmental, social benefits for all. So again, an appreciation for how our responsibility to everyone, not just certain types of people or certain groups of people, or certain pockets of individuals and countries and so forth, but everyone. It's going to require, again, this idea that people automatically think about the diversity of not just the individuals that are going to design solutions, but the people that are going to be impacted down the road. Ethics, ethical attitude and behavior, awareness and ability to work in diverse teams by, again, right here, ethnicity, gender, age, physical ability, etc., with mutual understanding, respect for all. So if we can accomplish this, where students actually walk out of our programs with this really keen understanding, awareness, and internalization even of the need to work on diverse teams, and diversity takes on many forms, right? And make sure people feel included. So there's this idea of inclusiveness. I think certainly we will have made great strides in building preparing students to be very successful. All right, the engineer and society, the graduate attributes profiles here, we talk about sustainable development, stakeholder consultation, and again, this is going to require, as it says here in the notes, ability to consult with a stakeholder from a wide cross-section of society. And in order to do that, again, you have to have this, it's a diverse cross-section, and so you have to have this concept of an appreciation for diversity and inclusion, again, not just on your teams, but the people that you're working with as well. The human, social, economic, and environmental impacts. Again, we talk about the human, social, economic, social impact to our customers, our end users, if you will. And so having the ability to evaluate these on people, and they come from all walks of life and from all areas of the world, again, is going to be a requirement to be successful in coming up with good solutions and achieving these SDGs. Our next one, individual and collaborative teamwork, role and diversity of the team. Of course, we talk about inclusiveness right here, that teams don't just diversify for the sake of diversifying, but also make sure that people appreciate the fact that their contributions are important to the team, appreciated, and feel that they're part of the team. So inclusivity is going to be as important as building a diverse team. You have to make sure everyone feels that they're part of the solution. And it talks about long distance settings, and I think this is especially true nowadays because so much of our work is done, remotely through electronic means, just like we're doing today. And so paying attention to that, I think, is something that we probably haven't done most recently, but we'll start to do that now, I think, more than ever. Communication, of course, that's critically important because people communicate in different ways, especially if they come from different cultures, different parts of the world. They have a different kinds of backgrounds, not just languages, but again, maybe their education and whatnot. But nonetheless, to communicate effectively, we have to make sure that we're considering not just my communications in my normal way, but how my communications might be interpreted by others. And so again, this idea of diverse audiences and thinking about that is going to be important. Okay, professional competency profiles. We talked a little bit about here about the applying local knowledge, and in this case, I guess the key changes are going to be in the eliminating the gender specificity. So you'll see in the introductory, those two introductory paragraphs or sentences, it talks about he, she, and so we want to make sure we get rid of that because there could be some individuals that don't identify with a specific gender, and so we don't want to discriminate or make them feel that they're not part of the of our teams and so forth. So we want to eliminate those where possible. Communication and collaboration, again, taking out the gender specificity here, again, to make it more inclusive. That's what we're after. And then, in this last one, continuing professional development, again, let's think about this gender neutral type of reference to make sure that people, again, feel that they're included. Adding the gender specificity doesn't really do there's nothing specific to a need to do that. There's nothing positive about that. So let's eliminate it. So with that, one last one, judgment. Again, talking about social, economic, environmental. Again, great opportunity, but we need to talk about diversity, but we need to make sure that we can eliminate this gender-specific references from the descriptions. And I think that's pretty straightforward to do. And so we'll, again, make that recommendation. And that's pretty much the summary of the changes that we're going to recommend in this area. And so I'd like to thank you for attending this webinar. And certainly if you have any questions on any of this, please bring that back to us as indicated in the communications. So thanks very much, and have a great day.
Thank you, Michael. And now we have all the 5 presentations give us a very good introduction about the changes and the reasons for the changes. Now we have some 20 minutes for the questions and answers. Here I have cited some questions from the Google Sheet and also from the chat box. Now, let me share my screen and to show the questions. So you see my screen?
Yes.
Okay. Now, actually, the very first question is about will the slides of these presentations be available, and where is it available? Let me answer this question. It is available on the WFEO website. And go to the WFEO website, you will find a portal of the consultation of the GAPC. And from there, you can find all these presentations and the relevant documents, including the original version of the GAPC. So let's go to the third question. Is industrial training important for achieving the graded attributes? I will not read the whole question. Could Professor Özgüler to make an answer to this question?
Yeah, I have written an answer on the chat screen. But the basic thing is that industrial training is not important for achieving the GAs, because GAs describe the attributes and the qualifications of a graduate at the time of graduation from the program. So, but this is very important, industrial training is very important to the professional competencies. Okay, I think it should be clear when you say that GAs concern outcomes at the time of graduation of an engineer. There are a couple of other questions directed to me. Would you allow me to answer?
Please.
Yeah.
Please continue.
One question was from WYTU. What is the best way to measure ethic attribute? That was the question. Now, of course, depending on the length of the program, it may be possible to add a separate course for ethics. If it is possible, that's the best thing. And there you can give case studies especially with examples of the particular discipline that the program belongs to. So the case studies really would be the best way to make sure that all the components of the ethics attribute is given to the potential graduate. However, since this is an outcome-based assessment, it's not necessary to do this in one course. This can be implemented in separate courses by way of examples and case studies. And I have I have seen a lot of programs doing it this way. Yeah, the other question, there was a question by Professor Clark, or a comment by Professor Clark from ICEE UK. Of course, they are not specifying in IEA in any of the graduate attributes, etc., the length of educational program. Since it's outcomes, again, we are concerned with measuring and assessing the outcomes. The only place where the length occurs in GAPC is, it says normally, for instance, Washington Accord GA can be achieved normally with 16 years of education. That's the only thing. We have given some years, both myself and Dr. Kanga, to distinguish engineers programs from technologist programs and technician programs. But that's all normally. It's not a specification, okay? That's another answer I would like to give. There were a couple of questions about post-pandemic world. How do you handle that? Well, that's actually why we are really consulting you. We have made our best to reflect our experiences from this pandemic experience, but I don't know if we could achieve all of it. I mean, all necessary components. So we are open to suggestions there. Okay. Of course, the mode of education has changed, and we expect that we have lots of difficulties in implementing these graduate attributes in the curriculum. So that's why we need a lot of help at that point. Yeah, that's, I think, the ones that directly concerned me.
Thank you, Professor. Let me ask Marlene to answer some questions. Marlene, please.
Yes. Do you want to direct the question, or do you want me to just choose a question?
You can choose question.
Okay. Let's open the sheet. Yes, so there was a question here about whether the GA should be formulated by universities as engineering programs. I think the GA is a benchmark, and universities have to formulate their programs, and they are accredited by their national accreditation bodies. So there's another element there, another level that needs to be considered for that. And I might also answer the question from Mr. Matalanga of Kenya, who asked how many years experience for a graduate before he becomes a professional. The requirement is 7 years under the professional competency framework. I'll pass that back to someone else now.
Have you finished?
Marlene? Yes, I finished. Thank you. Yes.
Okay. Thank you. Mr. Kang, could you answer this question? Is social responsibility considered within ethics and data management and post-pandemic efforts profile? Mr. Kang, could you answer this question about social responsibility and ethics?
Which question is it on number 2? I could not see the question very clearly. Can you put it? This is a full screen.
Can you see my screen now?
Yeah,
the first question.
Social responsibility considered within ethics. Well, this is in fact a very, very good question. You see, although the social responsibility has some interconnections with ethics, I think they are, obviously different angles. You see, ethics is a kind of, standards for people to act morally, or that by basic instinct, what is correct and what is incorrect. You see, and that in that, I think very many Chinese people have been trained with Confucius teaching that he has to be one person, either he or she has to have a very good ethical or standard as the first important thing. That is to say, or no matter how specialized or how professional, how expert this person is, without good ethics, this person cannot be a very good person. And in fact, sometimes this may cause problems. But as to social responsibility, is something that one part of the ethics, that is, one person has a responsibility to offer good service to society, so as to make sure that the society can develop and prosper, and people within the society may get, very well developed. So as to the pandemic, post-pandemic effect profile, I think we from China, especially the intellectuals in China, have been thinking and experiencing the pandemic here very clearly. And we are thinking fairly deeply on the social responsibility as a collectivity, that not only the individuals, but also a collective body that forms the social strength that can work together in the face of big disasters like natural disasters, or even health matter like pandemics. You see, China has, I think, set a fairly good example by the people getting together, unanimously taking the call from the Chinese government to strictly, behave themselves, lock them down in homes in order to prevent the widespread. So this is what I'm thinking. I have a deep experience in this. I'm now retired. You see, my wife and I have stayed at home for more than, more than 1 month at home in order to, have our social responsibility, spread over to the whole of the society, not to have this pandemic spread over to the whole of the society. So I think we may have some very good, experiences to share with our colleagues from the engineering, in the engineering community from all over the world. Thank you.
Thank you, Mr. Kang. Professor Tan, would you like to answer the last question? Can these attributes be applied appropriately for use as descriptors in developing national qualification frameworks for engineering education, and other questions if you like?
Yeah,
please.
Usually the president, the national qualification framework is the usually making for the quite similar for the kind of the substantial equivalence to each other. And for a brief answer, our IEA GA is a very good reference to drafting the national qualification framework, especially for the engineering educations. Because as you know, the engineering education is the sector of the tertiary education. In this case, it is quite different from the other education. Usually, it composed of quite similar to the Dublin Accord, which is we call as a diploma level, and for the Sydney Accord, it is relevant to the technology program, and the Washington Accord is for the engineering program. And this graduate attribute will be, it is supposed to understand what is necessary for outcome of the student when if they finish the program. This is the first answer. Another question I like to answer is industrial training important for achieving the GA? What would be a typical minimum duration and so and so? The for my experience, industrial training is very important for the engineering program, because during the university time, the student will be able to understand what is the professional practice, what he will be preparing for the future career as an engineer. If he become as a professional engineer, he must be going through the industrial training program. Usually, in our case, we usually spend more than 8 weeks. Usually, it is done in the final year of the program. I think it is enough answer.
Good. Thank you, Charlie.
Yes.
Here is a question at the bottom. Is that useful to include the industrial element into the communication and team working skills? What's your opinion?
Yeah. For the communication, you can see in the other professional area, communication is very important. Because as you know, our engineering practice and our engineers have a mobility. The engineers can move through any country. He will be working through different language, different people, different society. In this case, communication is very, very important for us. Therefore, we need to support, we need to provide the communication program or communication training or communication supplement, not only in the classroom, but also in the other mode of the teaching or learning. Thank you.
Thank you, Professor Tan. Does any other panelist would like to answer some questions? Professor Özgüler.
Yeah, first let me enhance my answer to industrial training question. Yes, some of the GAs, the knowledge and attitude required there can be incorporated into the industrial training kind of experience in the duration of the educational program, but not all. But industrial training, what is meant is summer practice kind of thing. Yes, some of the knowledge, belief, and attitude can be incorporated into that. The second comment I would like to make is, if you allow me, about the social responsibility.
Yeah.
There is a very nice answer on the chat by Alison Lawless. It says, should there not be a distinction between ethical behavior and professional behavior? Surely considering social and other elements relate more to professional behavior than ethics. So actually, just in the row, in the graduate attributes above the ethics, the title is social responsibility, about the social responsibility. The title is Human, Social, Economics, and Environmental Impacts. So social responsibility as a term, although does not occur in that, it is incorporated into that attribute, okay?
Yeah.
So those are the things I would like to mention.
Thank you, thank you. Would other panelists would like to say short words about the question? Okay, please.
Yeah, Professor Gong, I think I have found through the chat model saying that there is a friend called Priyan Dias who has written that I think engineers should be a little more critical of governments, but very much more sensitive to the needs of especially marginalized people. I think this, Priyan's argument is very good, but from my experience, from Beijing, I think so the relationship between the engineering and medical community and the government is a kind of a mutual help, mutual promotional, especially at time of emergency like this COVID-19. From the very beginning, not many people know what to do. Even the top leaders of the government, Chinese government, did not know what to do and how to do. And at this critical time, very important engineers from the Chinese Academy of Engineering strictly recommended to the Chinese government, saying that the city of Wuhan must be locked down and immediately. Otherwise, it will be a chaos. Then the government took the advice from this engineer. And then another member of the Chinese Academy of Engineering suggested a tentative but movable, simple but high quality hospital. A clinical hospital should be built up immediately using some stadiums or public houses to concentrate those people who are ill. Then immediately the government of Wuhan took this advice and immediately built thousands of hospital rooms. So I think from this you can see there is a very good and mutual promotional relationship between the government and the scientific and engineering community. Thank you.
Thank you, thank you. Please, we run over the time. Please allow me to say a few words about the next work. Here I will share my Can you see my screen?
Yes.
Okay, so let me say a few words about the works after the webinar. Thank you for joining us in the webinar, but this webinar is the start of the consultation process. Please go to visit the special portal at the WFEO website. From there, you can download relevant documents and view the record of this webinar. That will be soon uploaded in a few days. And then you can download a comment form, a form for the comments to the proposed updating. And there is an online survey for you to answer on that special portal in the WFEO website. And please complete the comment form and the survey by the end of August. That is the 31st of August of this year. And these comments and suggestions will be collected by the working group and posed to the IEA's government group and the WFEO Executive Council. So please keep the deadline, that is 31st August 2020. So, we have a lot of good comments you have written in the chat box. And there is still some questions have not been answered in the question sheet. And we are going to summarize the answers of these questions and upload to the website also. So ladies and gentlemen, thank you so much to join this consultation webinar. I think all of us know the importance of engineering education for the global engineering development or the national engineering development. And all of us also know the importance of a benchmark standard, or in other words, we call it graduate attributes and professional competencies, are so important for ensure the quality of the engineering education. And it is the first time for the WFEO member organizations to engage in the updating of IEA's GAPC framework. I firmly believe with the actively participation of the WFEO member organizations, they are from about 100 countries in all continents, will make a very important contribution to this updating and help them to be better meet the requirement of sustainable development and the requirement raised by the fourth industrial revolution. Now, please allow me to declare the end of the webinar with a heartfelt thanks to all speakers and all participants. Good day to all of you. Thank you for participation. Thank you. This is the end of the webinar. Thank you. Bye-bye. Bye-bye.
Bye-bye. Bye-bye.
Bye-bye.